Now that we've talked a little bit about Gaussian surfaces and the idea of those hidden charges, we're going to pull it together. This is going to introduce the idea of flux, and flux is going to be key to Gauss's law. So there's a few terms here that are going to be a little bit tricky, and I'm just going to start off by saying, and I'll come back to this multiple times and in multiple ways, flux is Latin for flow. Remember that field lines aren't necessarily moving. They're arrows. That's just because they're vectors. So nothing is moving here, nothing is flowing here. And the reason that's important is because just the way we use English to talk about this, it often sounds like something is moving. We say passing through, but no motion is actually happening. So if we return to our original situation of hidden charges, we see that there are three situations. We had all of the arrows facing out, and we would call that an outward net flux. We have in arrows, and we would call that an inward net flux. Now this last one I'm going to call zero. Now it isn't that there's just no field, and this will help clarify what I meant by inward and outward flux for the previous ones. I haven't defined it yet, I know that, and even the next video will really get into this. But we see here, because again we have the inside and the outside of our surface, these are pointing in, these are pointing out. And so if we say that I have 3 on the inside and 3 on the outside, well, your net is then 0. So we typically, for instance, might call inwards negative and outwards positive, and so you can see then how that would sum to be 0. So flux has to do with are our lines on our field lines on our Gaussian surface pointing out, pointing in, or do they kind of cancel out? And it gets more complicated in whether they cancel out completely, partially, and so on. So here they canceled out completely. So right now you can think about flux as just looking at the field lines and whether they are pointing inwards, outwards, or a mix, in which case we have to be a little more careful. So let's just look at this example to try to practice this. And again, in the next section of this chapter, we'll actually do something more with this and do math rather than just count. So in this case, net is again total. So we only have one field line per side. This is this very simplistic model. Our real field calculations won't look like this. So let's think about how many are pointing in and how many are pointing out. So in, we have 4 of them. So 4 of the sides have inward fields, the one on the back, the one on the front, the top, and the bottom. How many are pointing out? Well, the one on the left and the one on the right. Should have done that in a different color. So in and out. So in this case, when we add them together, if we say that in, for instance, is negative and out is positive, while it's mixed, they don't actually add to 0. The net is going to be inwards, and we could kind of quantify it and say that it's -2. But of course we need to put units on it and think about what these quantities actually are. But this is an example of what we mean when we're talking about flux. It's going to basically be inwards or outwards pointingness of vectors along a surface. That has to be close, so we can't just consider the front. We really have to consider every single side because that's what it takes to be closed. So all of these ideas are key to Gauss's law, so I hope you now understand something about Gaussian surfaces and something about flux. You don't have the whole picture yet for flux. The next section will cover it in detail, and we might start to understand, for instance, we just said it's in, but we see some of it is out. Is there actually a charge distribution that could create this hiding inside the box? And the answer is yes. This is when we start using our symmetry to think about it. So I won't go into that now. And if you feel like it's still a little foggy, please do keep watching the videos which will start applying this, and that might help you make it much more concrete.